So today, good morning children. Chapter number 13, surface area and volume. So you have got the previous knowledge from class 8 regarding cube and cuboids. You have done its area and its volume. So today you will be learning the formulas on cubes and cuboids regarding their areas and volumes. So now let us take cube. So now cube is a sixth facet, so there is a sixth face, so all the sides will be equal. Now you see, just to take the face of a cube, this is the face, so all the sides are equal. Let us take the sides as x. So that time this will be x, this is x, and all the sides remaining will be x, supposing. Now to get its area, that is the region enclosed by its boundary. So this is the boundary, every side is x. So to get its area, so to get the area of this square, you will get x into x, that is side into side. So that will be x square. So you have got the area of this face, area. Like this, you have got total 6. So you have got 6 face and squares. The shape will be the square. So here the area of one face, that is x square. How you got? X into x, x square. So the area of 6 faces, because there are total 6 faces. So now the area, that is the total. So the total area of 6 faces. So that means one face area is x square, then the area of 6 faces, that will be 6 times, so 6 into x square. Now say you are to find the lateral surface area which you have got in class 8. So lateral means leaving the floor and the ceiling. So the ceiling and the floor you will be not counting, you will be counting the 4 walls of the room. So now the walls will be 4. So this is 1, this is 2, this wall is 3, and this is 4. And these 2 are this is the base, this is the ceiling. That is why you are not going to count these 2. So now counting the 4 walls area, that will be called the lateral surface area. So now lateral surface area, so that means you have got 4 faces. So 1, this is 2, this will be 3, and this is 4. That means you are not going to count the base and the ceiling. So now leaving the base and the ceiling, you are going to count the remaining 4 walls. That is called the lateral surface area. So now you have got 4 faces. So one face area is x square. So then 4 faces. You will get 4 times of this. So it will be 4x square. This is called the lateral surface area, or it is also called the area of 4 walls of a room. Okay, 4 walls of a room. So now lateral surface area of a cube, or the area of 4 walls of a room. So the total area you will get 4 into x square. So you got 4x square. Sometimes the cube is open one. You will get an object, shape will be cube, and the upper part will be open. That means there won't be any surface. So now in that case you have got the 5 faces, because the upper part, supposing it is open. So that time if it is open, then you will not get here surface. So that means you will get the total surface 5. How? There is the base will be 1 and the remaining 4 walls. So this is the first wall 1, this is the second wall, this is the third wall, and then this is the 4th wall and the base. So the cube is supposing open. So that time to get the total area. So area of area of 5 faces of a open cube. Now the cube is open. Okay, the cube is open. So you are not going to count the upper face because there will be no surface. So now each face they will look like the square. So that is why area of a square you will get x into x square. Now the surface is 5. You have got 5 faces. So that means the area of 5 faces of an open cube you will get 5 times. So 5x square. That means 5 times of this. So now here the total surface area of a cube. So you got 6 into x square. Then the lateral surface area. So you got 4x square. Then you have got the area of 5 faces of a cube. So you have got 5x square. Then now next is the length of diagonal. The length of diagonal of a cube. The length of diagonal of a cube equals to the length of diagonal of a cube. So now supposing you are going to keep one longest rod inside the room. So that rod, supposing you are keeping it horizontally, that will not fit, or you are keeping it vertically, that will not fit. So sometimes the rod will be kept this way. That means inside the room. So this is called the diagonal. So to get the length of this diagonal, how to find? So the length of diagonal of a cube, which you have got in class 8. So that will be √3 into side. √3 into side. So you just put this value. Side means they will give the length of the side of the cube. So that time √3 into side, whatever you will get, that will be the length of diagonal of a cube. Then now let us take once more here. So here the side is the x, all the sides are taken as x. This is a cube. Now the total surface area, that is TSA, total surface area of a cube. So now here you have got 6 faces. Each face looks like the square because as I have shown you that this is the square where the sides are equal. So here each side is taken as x. So now to get its area, what you will do? So you will multiply these two dimensions. So x into x, you have got x square. So this total area is x square. Now here you are going to find the total surface area of the cube. That means you will find the area of the 6 faces. So that means you will get, that will be 6 times of this. So there will be 6x square. 6x square. Number 2. Now you are going to find the lateral surface area. So lateral surface area of a cube. This is also called the area of 4 walls. Area of 4 walls of a room. So 4 walls. That means you are not going to count the ceiling and the floor. You are just going to count the 4 walls. So that is called the lateral surface area. So now you have got here 4 faces. Each face will look like a square. So that is why there will be 4 times. So 4 into x square. So 4x square. Next is number 3. Area of open cube. Area of open cube. Open cube. Now the cube is open. So now you are not going to count the upper surface because it is open. So there is no surface. That means leaving this upper face, you have got remaining 5 faces. So that is why area of the open cube, so that will be 5x square, because the number of faces is 5. So 5 times of this area, 5 times of this area, because like this you have got 5. Then number 4, let us count now the volume also, because there is volume also. Now volume of a cube, so volume of a cube, so the volume, so here the dimensions will be 3. So now here to count the volume, that is the amount of space occupied by the container, how much space is there inside the container, maybe a room, maybe a container, maybe a can, anything. So now you are going to find the volume of a cube. So now here to get the volume of the cube, you are going to take 3 dimensions, that is, this will be, you will take, supposing this is length, same as this is breadth, and this is the height. So x into x into x. So now here that will be x into x into x. So you got x cube. This is your formula now. Volume of a cube. So you got x cube. X is the side. So here side of the cube. Then next one, let us take cuboid. Now the second one is the cuboid. This is the cuboid. So here cuboid will look like this shape. So here this is the length, this is the breadth, and this is the height. So these are the heights. You have got 4 heights, and then you have got 4 length. 1, 2, this is 3, this is 4. These are all the length. And then this is the breadth. This is the breadth. So you got the breadth. So this is also breadth. This one and then this one. They are the breadth. And these are the heights. Now this is cuboid. Here the length and height, they are not same. But here in the case of cube, you have found the edges are all equal. So here now you have got 3 different dimensions. That is the length, breadth, and the height. Now you take number 1, supposing. So here number 1 for the cuboid. So now here the total surface area. So total surface area of a cube. So of a cuboid. Now the total. That means you are going to find the area of the 6 faces, because in cube and cuboid you will find total 6 faces. So now the total surface area of a cuboid. So now how to find? To get this area, to get the area of this face, what you take? You take length into height. Supposing this is the one, so this is the height. Now here this is the height. So this is length, this is height. So you have taken the area, so it is length, height. Supposing, so you got this face. So now the opposite of this, you have got one more face. So this is the front face, this is the back face. This one is the back face. So now here in this face, you have got, this is the length and this is the again height. So that means you have got double. So plus LH. That means you have got the front face and the back face. Then again plus, you take this face, adjacent face. You take this face. So this is the breadth and then this is the height. So you take breadth into height. So you have got one more opposite face. So that is, in this face, area is breadth into height. So it will be breadth, height. Then you have got the opposite face. So the area will be same. So breadth into height. So this is the one. So here this is breadth, this is height. So here you have got breadth, height plus. Then so you have counted this face, opposite face, this face, and then this face. Now you are left with the means this face. So it is, now you take this base, you take this one. So now here in this one, this will be the length, this will be the breadth, because you are counting this. You are counting this one. So this is length, this is breadth. So the upper part is this. So this is length, this is the breadth. That means you have got two similar areas every time. So that means one is the front side, one is its back. That is why now in this area you will take length and breadth. So the opposite is this. So opposite is this surface. So this will be length into breadth. So length into breadth plus length into breadth. So LB plus LB. Now you add it. So here you got twice of LH, that is length into height, plus adding these two, you have got twice of breadth height. Then adding these two, you have got twice of length breadth. Now you take here common. So here 2 is common. So you take this 2 out and then the bracket. So LH plus BH plus LB. So that means this is your formula. So the total surface area of a cube, you have done it in class 8. So now the total surface area of a cuboid is directly twice of length plus breadth height plus height into length. So this is your formula to find the total surface area of a cuboid. That means you have found the area of the 6 faces. Then let us take the next one of this. Let us take number 2. Number 2. So here now the lateral. So the lateral surface area, which is called the area of the 4 walls. So that means you will not count the base and the ceiling. So you are just going to count the walls. So here this is called the lateral surface area of cuboid, or else you say area of 4 walls. Area of 4 walls equals to, so now you will count these 2. So here you will be counting this wall and the opposite is this wall. So here in this wall the dimension is breadth into height, because this is breadth, this is height. This is height, this is breadth. So now you are going to count this area. So this one, so it is breadth into height. So you do breadth height. So you take the opposite. So this is the one. So breadth into height. So it is breadth height plus you take this wall. So this one, front wall. So here the dimension is length into height. So this is the wall, front wall. So it is length. This is the height. So LH. So length into height plus, so you take the opposite. Opposite is this one. This is the opposite wall, where this is the length and then this is the height. So you have taken this one. So this is the front wall, this is the back wall. So you will get LH. Now you add these two, you will get twice BH plus twice LH. So if you take common between these two, you will get twice H. So in both the terms you have got common 2H, 2H. So you take 2H out. Then breadth plus length. So now twice height into length plus breadth. That means, or else you can write twice height into length plus breadth. So this is your direct formula to get the lateral surface area of a cuboid. That is the area of 4 walls of a room. So here you are not counting the base and the ceiling. So leaving out the base and the ceiling, the walls you have counted, and the formula is twice height into L plus B. So here L is the length, B is the breadth, H is the height. Then the next one. Next one, let us take the area of number 3, the area of open cuboid. open cuboid. Open cuboid. Now the cuboid is open, so there is no surface. Supposing this is a container, shape is cuboid, and this one is open. That means there is no surface on this top means shape on this upper part. There is no surface, but there is a surface on the remaining 5 faces. So now supposing that is open. So now how to get from the total surface area, that means from the area of the 6 faces, which is this, deduct this area. So that means length into breadth. This is length, this is breadth. Why? Because you are not going to count this area, leaving out this surface, that is the upper surface. You are going to count the remaining 5 surface. That is why from the total area, you just deduct this area. Then you will get the area of the open cuboid. Or else you can just delete this part, and then you can take these 4 walls and the base. How? So the 4 walls is this. So this is 1, this is 2, this is 3, then this one is 4. But you are not going to count this because it is open. So the upper surface you are not going to count. So the 4 walls and the base. Base is this. This is the base. Base. So that means the 4 walls. 4 walls is this. So there will be twice height L plus B. So there is the 4 walls. Area of the 4 walls or the lateral surface area. Lateral surface area plus the base. This is the base. So length into breadth plus LB. So you can write this way also. Then number 4, the length of diagonal. So the length of diagonal. So here you are going to find out the length of the diagonal. So joining the 2 opposite vertices. So suppose I have joined this one. So this is the diagonal joining the opposite 2 vertices. One is at the base, one is at the top. So you joining these 2 opposite vertices, one at the base, one at the top of the ceiling. So you will get this one as the diagonal. So to get the length of this diagonal, so here there is some rule. So there will know. So simply you write here that you will get L square plus B square plus H square. So using the root over L square plus B square plus H square, you will get the length of diagonal of the cuboid. So this is the cuboid. So you will get the length of this. So this line segment which is called the diagonal. So how to get? Root over L square plus B square plus H square. So L, B, H, they are the length, breadth and the height respectively. Then now the volume. Now the volume. So the volume of cuboid. So the volume, so here the dimension is 3. As I have told you that it is the amount of space occupied by a container. So that is why now to get the volume of the cuboid, you are going to multiply the 3 dimension. So length, breadth into height. So L into B into H. So L into B into H, if you multiply these 3 dimension, you will get the volume of the cuboid. So in the case of the cube, to get the volume of a cube, you have multiplied the 3 dimension x, because here since all the sides are equal, so you cannot say length, breadth, height, because the measurement of the sides are same. That is why x into x into x. So you do x into x into x, that is the x cube. So the volume of cube is x cube, that is the h cube. H means the side. So h cube. And the volume of cuboid is LBH, that is L into B into H. So this is your formula for the total formula for the cube and the cuboid. So based on these formulas, you are going to begin chapter number 13.1. So here you will get lots of formulas. So After this, you will get cylinder, you will get cone, you will get hemisphere, and then you will get the sphere. So we will be learning the formulas part by part. So today we will be just doing 2 more sums on this. So you are going to learn all these formulas. One is on cube, another is on cuboid. So these formulas you will need, and I know that you have got all these in class 8. So simply you go through this and then you will get the chapter easy. Let us take exercise 13.1. In this chapter, you are going to take the books because the questions are long, so I will be just reading out the question in brief. So here, question number 1. So it is given that a plastic box with length. So here a plastic box. So plastic box. So here the dimensions are given. So it is 1.5 meter long. So long means the length. So 1.5 meter. And the wide means the breadth. So here breadth equals to 1.25 meter. And the depth means the height. And 65 centimeter deep is to be made. So deep means the depth. That is the height. So height equals to 65 centimeter. Now here these two, that is the length and the breadth, they have given in meter, but they have given the height in centimeter. So you are going to convert the centimeter into meter. So for this, what you do? You just divide by 100. So 65 divided by 100. So it will be meter. So you will get how much? So here the number of 0 is 2. If you divide 65 by 100, decimal point will move after 2 places towards the left side. So it is 1, 2. So it will be 0.65 meter. So now it is given that, so a plastic box 1.5 meter long, 1.25 meter wide, and then 65 centimeter deep. So deep is the height. So height is 65 centimeters. So you have converted to meter. It is now opened at the top. So the box is open. So here the length, breadth, height, they are not same. They are not the same. That is why the shape is cuboid. This is not cube because in a cube all the sides are equal. So here the length, breadth, height, since they are all different measurement, this is a cuboid. So you are going to use the formula of cuboid only. So here it is given that, so the box is opened at the top. So ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. This is the first question. So here they have given that, determine the area of the sheet required for making the box. Now the question is, to get the area of sheet required for making the box, as the box is open, so they have given that box is opened at the top. So in the above, supposing this is your box, supposing this is a cuboid. So you take it that this is a cuboid. So all the box they have made with plastic. These are all plastic sheets. So they have made all these with plastic. These are all plastic. So but here the box is open. So here is no plastic. So that means now they have asked that you have to find out, determine the area of sheet required for making this open box. So open. So that means above this surface there is no sheet because it is open. So you are not going to count this. You are going to count the remaining 5 faces because all these faces are covered with plastic sheet because the box is made with plastic sheet. That is why you are going to use the formula. What? That is the area of the 4 walls. So there are 4 walls. So this wall made with plastic, the backside wall made with plastic, this wall made with plastic, and the opposite wall made with plastic, and this base also is made with plastic. But the upper one is open. That means there is no plastic. So that means you are going to count the area of 4 walls. 1, 2, this is 3, and this one is 4 plus the base. So that is why now area of sheet required to make the box equals to, so here you will take the 4 walls and the ceiling. So the 4 walls twice into height L plus B as I have shown you. So twice into height L plus B, and this one also you have got in class 8. So plus this is the 4 walls and the base. So this is length, this is what? Breadth. So length into breadth, you will get this base. So plus L B. Now you put this measure. So twice into height. So height is 0.65. So 0.65. Length is 1.5 plus breadth is 1.25. So plus you will get 1.5. So that is length into breadth. So length is 1.25 into 1.25. So now here this 2. So 2 into 0.65. So 2 into 5 10. 2 into 6 12 13. So 1 3 0. So 1 3 0, and then point will move after 2 digits. So 1 2. So 1 2. So into so this 2 you add it, you will get 2.75. So 2.75 plus, now multiplying this 2. So 1.25 into 1.5. 15 5s are 75. So it is 7. 15 is 30 plus 7 37, and then it will be 18. So you do the calculations at home, and then you will get 1875. Now the point will move after 3 digits. So there is 1 digit after the point, and there is 2 digits. So 1 2 3. So 1 2 3. So that will be 1.875. So you will get 1.875 equals to, now multiplying this 2. So 13 into 2.75. So here 2.75 into 13. So you leave out this 0. So 13 5s are 65. So you will get 6 in hand. 13 7s are 91. You will get 97. So it is 7 9 in hand. Then 13 2s are 26. So you will get 35. So 35. Now before the point there is 2 digit. So 2 digit is there, and then you have got 1.3. So there is 1 digit here. So it is 1.3. So you have got 3 digits. So 1 2 3. 1 2 3. So that will be 3.575. So 3.575 plus 1.875. So now you add it, you will get 5 plus 5 10. 7 7 40, it will be 15. 8 5 30, it will be 14, then 5. So it will be 5.45. So this 0 you can just ignore it. It can be, now since you have found the area, this will come in meters square. So now the first one is complete. That is the first part. Now the next one is determine the cost of the sheet if a sheet measuring 1 meter square cost rupees 20. Determine the cost of a sheet. So you have to find the cost of this sheet. That is, you have used this sheet to make this box. So the area is this. Now they say that you have to find the cost of a sheet if a sheet measuring 1 meter square cost rupees 20. So 1 square meter, that means 1 meter square, it costs 20 rupees. If you go to buy the plastic sheet, then 1 meter square, that will cost 20 rupees. So now the total area of sheet used in making this box is 5.45 meter square. So the area is more, so the cost will increase. That is why now second part. So you are going to find the cost. So here they have given that 1 square meter of the sheet, it costs rupees 20. So now cost of 1 meter square of sheet equals to rupees 20. Therefore cost cost of, so this much area. So it is 5.45 meter square of seat. So here the area is more, the cost will be more. So you will do into, so it will be 5.45. So now so equals to, you will get, now 2 into 5 it will be 10, 2 into 4 8, it will be 9, 2 into 5 it will be 10, then one more 0 is there. So here the, after the point you have got 2 digit, so the point will move after 2 digit, so it is 1 2. So your answer is equals to rupees 109. So your first one is 5.45 square meter and the next one is rupees 109. So this is your answer. So what we did here, they have given that the box is open and this box is made with plastic sheet. That is why you have not counted the upper face. Why? Because there is no seat. So the number of faces where the plastic sheet is used is 5. So 1, this is 2, this is 3, and then this is 4. This is 4, and then this one is 5. Except this top face, there is the ceiling. They have used the plastic sheet on the remaining faces. So the formula is, this is the area of 4 walls. So the 4 walls of the room plus the base. So you have counted this. So length into breadth. Then by putting these values, you have got 5.45 square meter. Now here they have given that you have to find the cost of the seat. So how much seat was used? 5.45 square meter. Now here they have given that the cost of 1 square meter is rupees 20. So for using 5.45 square meter, area is more. So that is why you have done multiply. So your answer is this two. So 109 and then 5.45 square meter. So that's all for today.